I will derive the second order elementary reaction mechanism here. Assume we have two different reactants, A and B. They react to produce P. The reaction rate is dP over dt. This is how fast the product is produced. Again, overall it's a second order reaction. It's K, the reaction rate constant, times A to the power 1 and times B to the power 1. So 1 plus 1 is 2. It's a second order reaction. So how do we tackle this problem? First we need to realize this. To make 1P, you need to consume exactly 1A. And exactly 1B. So basically the production rate of P is equal to the consumption rate of A is equal to the consumption rate of B. And also, if the initial concentration of A and the initial concentration of B are the same, we will have A equals B at all times. What if the initial concentrations of A and B are different? We will derive for that situation in a different video. So in this video, we assume A equals B at all times, and then it's very simple for us to simply just focus on this part. It's a simple differential equation. Whenever we can, we separate the variables, so we're going to do that right here. We have A on one side, we have K and T on the other side. Actually, K is a constant, I'm sorry. T is a variable here, and we integrate. I'm going to integrate this time from 0 to T, and to avoid confusion, I replace this dummy variable T with T prime, and T prime from 0 to T equals KT. How about this one? Again, it's from T times 0 to the actual time T. So we integrate this. The integral of -1 over A squared is simply 1 over A. So on the left hand side of the equation, you just get this T, and it's actually this. And if we look at this end and that end, this is the rate law for the second order reaction mechanism. The concentration of A at time T, you need to take its reciprocal is equal to the reciprocal of the initial concentration of A plus KT. So if you're to do some data analysis, if you have real data, I would recommend you to plot the reciprocal of A versus, and you have an intercept here, and you have the slope K here. So here you see a straight line, and the intercept is 1 over A naught, and the slope of the plot is K. Now we're going to look at the half time. What does half time mean? Half time means when the concentration of A is half of the initial concentration. So we just simply plug it in. K equals plus K. I'm going to use a subscript here, and this denotes half time. Yeah, now we can easily see that this is actually 2 over A naught minus 1 over A naught. You get 1 over A naught, and then the half time is just 1 over a naught, and then there's a k here.